All right, folks, so here we are at lesson 3-6, the quadratic formula and the discriminant. So this is my go-to tool. Honestly, you guys, if there's one thing that you remember from this whole section, 3-4, 3-5, and 3-6, this right here, this formula, this is what you should remember. It's going to be a pretty fail-safe way for you to get your roots if you're taking like an ACT test or any test where you need to know what those roots or solutions are. This should never fail you. So the objectives that you'll be able to solve quadratic equations by using the quadratic formula and use the discriminant to determine the number and type of roots of a quadratic equation. You have found solutions of quadratic equations by graphing, factoring, and by completing the square. There are some quadratic equations that would be difficult to solve using these methods. I would argue that all of these methods seem a little bit more difficult than just using this, but many people would disagree. The quadratic formula can be used to solve any quadratic. That is why I prefer it. So this is the quadratic formula. You will probably have this memorized by the time you're done with this course. You should have it memorized by the time you take the test, but just in case, I will say by the end of the course. So the solutions of a quadratic equation of the form ax squared plus bx plus c equals 0, where a isn't 0, are given by the following formula. So you probably have heard people sing this before. It's really cheesy, but basically it's like Pop Goes the Weasel. So they say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't do that. That's the one and only time you're going to hear that. You're welcome. Okay, so here's how we do this. These first two examples are going to be examples where there's two rational roots. So what that means is like there's two normal answers. So the first thing we have to do is we have to make sure that this side equals 0. So in this first example, unfortunately, it equals 33. So we just need to subtract 33 on both sides. And we're going to end up with x squared minus 8x minus 33 equals 0. So that's what we're going to look at now. The second thing that I would do, especially as you guys are just getting familiar with this formula, is to establish what a, b, and c are. So a, b, and c are the numbers, the coefficients in order. So a is like 1. In this case, b is negative 8, and c is negative 33. And then we would fill in our formula. So I'm going to look at this highlighted formula. What we do is we say x is going to be equal to negative b, or another way to think of that is opposite b. So instead of a negative 8, it's going to be a positive 8. Plus or minus, which means there's two options there. Two options, plus and minus. The square root of b squared minus 4 times a is 1 from here, times c is negative 33. Holy cow, that's going to be a big one. And then the whole thing over 2a, and a again is 1. Here's one thing to be really cautious of, you guys. A lot of students I've seen in the past, they just do the fraction line right here, and they exclude it from the 8. It has to be the entire thing divided by 2. So then when you simplify this, you end up with, you get x equals 8 plus or minus the square root of 64. And then let's see, negative 4 times 1 times negative 33 is 132. All divided by 2. I'm kind of getting squishy here, you guys. I'm sorry. Then we have, switch colors. This is really like 8 plus or minus the square root of 196 divided by 2, which is 8 plus or minus 14 divided by 2. So if you look at that as two separate things, if you look at that as 8 plus 14, that's 22 divided by 2. So I'm going to split this. 8 plus 14 is 22. Divided by 2 is 11. And then 8 minus 14 divided by 2 is negative 6. Divided by 2 is, maybe I'll just skip that. Negative 6 divided by 2 is negative 3. So those are going to be your two solutions. You know how it's normally x equals this and x equals that. That's what you're looking at on that one. Okay. I'm going to clear this off in a minute, but if you guys want to pause the video and try to do this one by yourself, I'm going to clear this writing in a moment so that I have enough space for the next one. It's kind of hard to write with these markers. All right. So next one, same thing. We got to follow those same steps. So what we're going to do is start by subtracting 30 on both sides, and we're going to get x squared plus 13x minus 30 equals 0. And then I would go a equals, b equals, c equals. A is 1, b in this case is 13, and c is negative 30. Then you're going to fill in your quadratic formula, which is up here. So we'll have x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. So we got to simplify this a little bit. There's something we're going to talk about in just a moment, but this piece right here is called the discriminant. I'm going to try to type that all into this graphing calculator. So we have 13 squared minus 4 times a times c. So that's 289. So we have negative 13 plus or minus the square root of 289 all over 2. The square root of 289 there we go. Second square root 289 is 17. So we have negative 13 plus or minus 17 divided by 2. So if you split those off, I like to usually write them separately. If you do 13 plus 17 divided by 2, that is 30 divided by 2 is 15. Then if you do, oh shoot, sorry you guys, I missed the negative. Negative 13 plus 17. That is a game changer, isn't it? Okay, it's negative 13 plus 17. My apologies. So that is 4 divided by 2, which is 2. Little different. Then we have negative 13 minus 17 divided by 2. That's negative 30 divided by 2 is negative 15. So your two solutions are 2 and negative 15. That's where this graph would, just so you have a context, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There, and 1, 2. It would cross like this. That's what it would look like. That's what we just figured out is the 2 and the negative 15. So those are the two examples if you have two rational roots. So the next examples are if you have one rational root. So let's go this color. All right, so this is if you have one rational root, which means it only has one real number, one normal number. So in this case, this first one, it's great. It's already equal to 0, so we're all set. So we can just say A, B, C. A is 1, B is negative 34, C is 289. All right. So then we fill in our quadratic equation, which is x is equal to opposite b plus or minus the square root of b squared minus 4ac. All over 2a. Ooh, that's a big discriminant. That junk under the radical, that's the discriminant. That's huge. Okay, so let's try to type that in. So we're going to have 34 plus or minus the square root of, let's see what comes out. Negative 34 squared. Okay, negative, I'm going to put this in parentheses. If you don't, it's going to mess it up. It'll come out wrong. So if you have a negative that you're squaring, make sure you put it in parentheses. Okay, 0. All right. And then divided by 2. Well, square root of 0 is just 0. So what we have is 34 divided by 2. So x equals 17. That's your only option. And that's because this guy came out to be 0. Okay? So the next one's an example that's very similar. If you guys want to pause the video, you can go ahead and try to find the solution here. So in this case, what we would do, we'd start it off the same. A equals, B equals, C equals. A is 1, B is negative 22, and C is 121. And then we fill in our quadratic formula. X is equal to opposite B plus or minus the square root of B squared minus 4AC. All over 2a. All right, we got another massive discriminant. The thing under the radical. It's another huge thing. Negative 22. Okay. Negative 22 squared minus 4ac is 0. Okay. All over 2, which means 22 divided by 2, which is 11. So, big thing here, one rational root is going to happen when that discriminant is 0, when that thing under the radical is 0. All right. Then we go to the back side. So this one says if we have irrational roots. Okay, same thing though. I'll write the formula up here. X is equal to negative b plus or minus square root of b squared minus 4ac. All over 2a. All right. For this one, a equals b equals c equals. A is 1, b is negative 6, c is 2. We fill it in. X equals opposite b is positive 6 plus or minus the square root of b squared minus 4ac. All over 2a. Oopsie. And again, make sure you include this part of the line. It's got to cover the 6 too. All right, these are small enough numbers. I think we can probably do it in our head. Negative 6 squared is 36. 36 minus 4 times 1 is 4 times 2 is 8. 36 minus 8. 36 minus 8 is 28 divided by 2. Then what's going to happen is we need to zoom in on this guy right here. Hopefully you remember this from geometry, but we're looking for two numbers that multiply to 28, and one of them we need to be able to square root. So here's what I mean. 4, you can square root. It's a pretty square root. 4 times 7 is 28. So really we're looking at like square root 4 times square root 7. The square root of 4 is 2. Square root of 7 is trash. So we just leave it like this. So now instead of that root, we have 2 root 7. And then what's going to happen is my teacher in high school used to say, if it's a heart, break it apart. So you can split this into x equals 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1. So this would be your solution. There's 2 in there, 3 plus square root 7 and 3 minus square root 7. If you guys want to pause the video and try this next one, it's maybe a good idea. I'd maybe at least pause it and try to figure out how to simplify radicals. If you're struggling with this, search up a video on simplifying radicals. Simplifying radicals. Simplifying radicals. Okay? All right. So I will finish this one and then I'll start I'll start a new video after this. So we're going to go A, B, C. A is 1, B is -5, and C is 3. So you're going to go x is equal to opposite b. So 5 plus or minus the square root b squared minus 4ac all over 2a. Okay? So then we have x equals 5 plus or minus the square root. All right, 5 squared is 25 minus 4 times 3 is 12. So that's 13 divided by 2. Square root of 13. 13 is prime. So there is nothing that can split that up. Like we can't simplify that radical. We can't do that. So we're done right here. This is it. 2 solutions. 5 plus square root 13 divided by 2. 5 minus square root 13 divided by 2. All right, I'm going to stop this video. I'm going to start a second one just so this doesn't get like horribly long or get cut off.